tonight. More than $120 million will be set aside to groom talent for the infocom sector. The focus is on students and working professionals at various levels.
A public Wi-Fi network that's twice as large and more than 2 times faster than it is right now. That's coming your way by 2018, and it's set to benefit not just the public but businesses as well.
And by the end of the year, a scheme to help those in public rental housing own a home again will kick in. Eligible families will get access to perks, but these come with some tough conditions to encourage personal responsibility. Good evening and welcome to Singapore Tonight. I'm Dawn Tan.
And I'm John Liao. Thanks for joining us.
Our top
Strong earthquakes can cause massive damage and loss of life, so it would be useful to have a reliable way to forecast when and where they're going to happen. Now, a team from the Earth Observatory at Nanyang Technological University says they found a new way to do so. To tell us more, I'm joined by one of the 2 scientists behind the study, DeepaMV's. Welcome to the show.
Thank you.
Deepa. Now, Deepa, the majority of the scientific community believe that massive earthquakes are unlikely to occur following light tremors or earthquakes below 2 on the Richter scale. Now, your study says quite the opposite. Tell us more about it.
Yes, our study shows that slow movements can occur before devastating earthquakes. So first let me explain about slow movements. So during the slow movements, what happens is rock blocks move slowly across this fault, and it prolongs several days, weeks and months, so it's possible to monitor them and use them as forecasting tools.
And just to be sure, this is the fault line right down the middle over here.
Yes.
Okay, now what happens during fast movement?
During fast earthquakes, what happens is the rock blocks move, of course, it's fast, and they move several meters in several seconds.
Way faster than a
Way
slow
faster
movement.
than slow movements. So it's very hard to predict earthquakes as such. So when we have slow movements before them, we can use them as forecasting tools.
Right. So let's use California as an example. We know that it's an area that's quite that has a history of quakes. What can you tell us about the patterns over here?
So in California here we have the Pacific plate and North American plate, and what you see here is the San Andreas fault. So several major earthquakes happened over past so many years, and in here on an average large earthquakes occur around 150 years of time. So in our study we were focusing on this place called Parkfield. We were looking at a particular tremor family called Parkfield tremor family. The interesting thing is that they were occurring every 3 and 6 days, and they were rupturing the same place over and over, like hundreds of cycles. So using our model, we explained this pattern using the slow and fast rupture in the same asperity. Now we are extending this study to Japan.
Right, and let's just bring out that graphic of Japan as well. Why don't you tell us the similarities or if any differences between California and Japan?
So in the case of Japan, what you see is the Pacific plate is diving beneath Japan, and here in Japan the largest earthquake ever hit was in 2011, Tohoku earthquake, 1909. So the interesting thing is at the same place there was a slow slip event before this devastating earthquake. So the similarity is in the same location we have slow movement and fast movement. The difference is in the case of Parkfield there are hundreds of tremors happening over and over. Here only few cases in a very short time span.
And taking all that information together, what is the team's takeaway?
So the basic the takeaway message is that the same patch can rupture slow and fast. So if there is a slow movement continuously happening in a location, it doesn't mean that it is safe. So a devastating earthquake can occur in the same location. That is the main point from our study.
So that brings us to the next question, isn't it? Let's talk about a possible earthquake happening in the region sometime soon. Sumatra, 2004, that of course comes to mind. What are some of the patterns you'll be looking out for?
In the case of Sumatra, first of all I want to say that many scientists at Earth Observatory of Singapore, they are focusing on earthquake hazards in Sumatra. So in Sumatra what you see is Indo-Australian plate is diving beneath the Sunda plate. So this line is the Sunda megathrust. Over many decades in the last decade, many earthquakes were rupturing this Sunda mega thrust, and this patch called Mentawai patch, this is the only place which didn't fully rupture for past 2 centuries. So scientists at Earth Observatory Singapore believe that this patch can rupture any time in the next few decades.
So that being the case, this being the so-called a prime spot, what are the scientists doing to sort of hopefully preempt such a disaster from happening?
So if we take our team, earthquake physics team, we are developing marine instruments to actually go over here and do some measurements of these movements. So we will be in future we will be able to measure these movements, and one day we can use them to forecast.
Yeah. Okay, and we wish you the very best of luck in that endeavor, because that quite honestly could be the difference between survivability in such an event. And that was DeepaMV's from NTU's Earth Observatory. Back to you, Don.
All right, that's all the time we have on Singapore Tonight. Thank you for your company. Don't forget you can find us on Facebook and Twitter as well, so we'll see you there. Good night.